Hi again. So in this video, we want to talk about types of experiments. And basically it's how to design selection of different groups for your experiments. And so the first design is very simple. Well, let me start you off with an example. And this is example about discussions that take place. It's based on the discussions that take place in our department meetings because some instructors believe that textbook homework is the best. Some instructors argue that online homework's way better because students get immediate feedback about whether they're doing good or not, whether they're on the right track or not, whether like with text homeworks is not available. And then some instructors believe that no homework is the best. And I like one of the instructors that I talked to, she said that she feels that homework is good to a certain extent, especially for students who are struggling. They need more practice, so homework could be good. But there is a point where a student doesn't feel good about it when it's overdone, when it's extensive. So there's always a discussion: what's the best option, and how no homework, textbook homework, or online homework, and if there should be homework, then how much of it should be assigned. It's always a discussion, and different people feel differently about it. So let's say that we wanted to test the effects of no homework, um, and then the textbook homework, and the online homework. So let's say that now I have a class of, let's say, 45 students, and I randomly assign each student to one of these groups by, I don't know, a random number generator, or flipping a coin, or doing our hat technique, one of those, just based on randomness. So this is going to be our, it's a completely randomized study. It's called completely randomized. And so I think it was left over on the other page, completely randomized experiment. And well, it's very similar to our random sample from a population, except here everyone in the class gets assigned to a different group. So it's not a sample from a population. But okay, so the next well, but let's say the danger with this experiment is that just by chance, let's say more people who scored really high on the first exam, let's say that they majority of them end up in the no homework group. It is possible. Then how do we avoid that? So to avoid that, we're gonna kind of do similar what we did for a stratified sample. So the technique is similar. We are gonna divide our students into two groups prior to assignment, two different treatment groups. So let's say in one of the group, let's say I have my first exams grades in already. So I'm going to select in the first group A or B students, A or B. Or the ones that got A's or B's on the first exams. And in the second group, I'm going to put the people who got C or less on the first exam. And then I'm gonna randomly select people from the first group into one of these three groups, and then people that got C or less in the first exam also randomly assign those people from that group to those same groups. Okay, so in treatment 1, I'm gonna have some people from A or B group, and also I'm gonna have people from this group that got C or less, and similar for the other 2 treatments. Okay, let's talk about matched pairs. So I have, and by the way, the name of this design is a block design. Okay, so this is a block design experiment. And then the next is the matched pairs design. It's basically a reduced block design, where your block contains only 2 subjects or 2 groups. I have to divide. I have only 2 groups to assign my subjects to. So, for example, maybe I want to look into homework versus no homework. So those are going to be our 2 categories, and then I will select pairs of people that are similar. So for example, I will have in the first group, I'm going to have a student who got an A, and that means on the first exam, and that means that in the second group, I'm going to match that person with another person who got an A in the first exam. And then I have to think about other factors that may contribute to their learning. And so I know that males and females learn differently. So maybe if I select a female here, I should match with a female in a second group study. And then also, for example, if I know that this person is using tutoring, the fact that the person uses tutoring means that they are motivated, they're self-starters, and if they don't know something, they're willing to basically reach out for help and advocate for themselves. So this could be a factor in their grade. So I should match that student with a similar student. So I will also look for students who uses tutoring. Okay, so so this way I'm matching similar people with similar characteristics. So then I may get a male who got a B or on the first exam and does not use tutoring. I will match that person with another person who also got a B, a male who got a B on the first exam and does not use tutoring. And so forth. I will continue this pattern. And so this way, I'm gonna select my, assign people to the groups as matched pairs. So some of the examples of matched pairs experiments is when we compare twins. For example, so the assumption is that they get same set of genes, but maybe they were raised in different environments, and to see how that environment, what percent of their traits is defined by the environment. And what comes to my mind is the movie where that starring Arnold Schwarzenegger and Danny DeVito and twins. So that's the idea. Of course, that's not a scientific movie, but there are studies that compare twins. Also, before and after studies, that's another example of of a matched pairs. In this case, the person who's tested before is matched with the same with that same person, but after the treatment. And an example could be one of the studies that I already told you about the power pose. How does power pose that you practice before an interview affects the outcomes of your interview? So you go in on the interview without any treatment, and how your presentation compares to you being interviewed after you practice this power pose. It turned out that the difference is very big. And I will link that video that talks about that experiment to this video. So if you want to take a look at it and learn more about what I'm talking about, you can. And I'll see you in the next video.